Hello guys, this is fourth lecture in the series of digital electronics. In the last lecture, we have studied number systems, radix, symbols, and the binary number system in detail. In this lecture, we are going to study octal number system and hexadecimal number system in detail. Octal number system has 8 symbols 0 to 7 and hence its radix is 8. This table shows the octal counting. You can see here in octal numbers 0, 1, 2, 3, 4, 5, 6, 7 up to 7, these numbers are same as the decimal numbers. That means the octal equivalent of 6 is 6 or octal equivalent of 7 is 7, but after that 8 is 10 in octal number system or 9 is 11 in octal number system. So here it changes. Now how the octal equivalent of a given decimal number is calculated? The same method that we have seen in the binary number system. To convert any decimal number to the other number system, the decimal number is divided by the radix of that other number system. So while converting decimal to binary, we have divided the given decimal number by 2, radix of binary. Similarly here, to convert given decimal number into its octal equivalent, the given decimal number will be divided by the radix of octal number system, that means 8, right? So let us see an example. Again, the decimal from the given decimal number, the integer part and fraction part are converted separately. So let us see the integer part of decimal number. If we consider a decimal number 318, to convert it to its octal equivalent, it will be divided by 8. The quotient and reminders are written like this. The quotient is again divided by 8. Here you will see this is again the next quotient. So 8 4s are 32 and 7 will be the remainder here. This process is repeated till the last remainder is less than 8. So here 4 is less than 8 and this last remainder is transferred to the queue of these reminders. The reminders taken in reverse order gives you the octal equivalent of given decimal number. So what is the octal equivalent? Reminders in reverse order 4, 7, 6. So 318 in decimal is equal to 476 in octal number system. See here, all the numbers are between 0 and 7. Let us see the fraction. If we consider 0.65 a fraction part, then it will be multiplied by 8, the radix of octal number system. So it will be multiplied by 8. From the product, the integer part is taken aside as carry and fraction is again multiplied by 8. So this fraction 0.20 is multiplied by 8. From the product, again the integer part is taken aside as carry, fraction part is again multiplied by 8. This can be repeated. Now these carries taken in forward order. See, you have to remember this. These reminders are taken in reverse order, but these carries are taken in forward order. So the carries taken in forward order gives you the octal equivalent of given fractional number. So 0.65 in decimal is equal to 0.514 in octal. So totally in all 318.65 in decimal is equal to 476.514 in octal, right? We'll solve some more examples in the coming lecture. Let us move forward. The octal to decimal conversion. Octal to decimal, that means the reverse conversion now. And let us consider an octal number 452.37 and convert it to its decimal equivalent. So what is done? We have seen in binary number system also. Method of weightages. We have to calculate the individual weightages of these individual digits. And how the weightages are calculated? By multiplying the digit by the power of radix. Here radix is 8 and hence 3. Now from integer part, this 2 is near this octal point and hence 2 will be multiplied by 8 raised to 0. 2 into 8 raised to 0. Next 5 into 8 raised to 1. Next 4 into 8 raised to 2. On the right hand side of octal point, the digit will be divided by the powers of 8. So 3 into 8 raised to minus 1 means 3 by 8 plus this 7 into 8 raised to minus 2. So negative powers of 8 are used to multiply or to calculate the weightage. When you calculate this gives you 256, this gives you 40, this gives 2, 8 raised to 0 is 1. So 2 into 1 is 2 and this gives 0.375, this gives 0.109 and totally you get 298.484. So this is decimal equivalent of given octal number, which is calculated using method of weightages. The next number system is hexadecimal number system. Hexadecimal number system is an alphanumeric number system. Alphanumeric means in the symbols it has numerals as well as alphabets. So what are the symbols? From 0 to 9, these 10 symbols, plus from A to F, these 6 symbols. So total there are 16 symbols and hence radix of hexadecimal number system is 16. This table shows you the hexadecimal counting. So obviously 0 to 9 will be the same digits, equivalents, hex equivalents of decimal numbers. When decimal becomes 10, it is A in hexadecimal number system. 11 is B in hexadecimal. 12 is C. 13 is D. 14 E and 15 F. So 0 to 15, 16 symbols. When it goes to 16, it is 10 in hexadecimal number system. We'll see how it is 10. Now let us see the conversion. Decimal to hexadecimal conversion and hexadecimal to decimal conversion. For decimal to hexadecimal conversion, again the division method is used, which is also called as hex-double method. We have seen the division method in binary is called as double-double method. When you are using it for octal number system, it is also called as octal double method, and when it is used for hexadecimal conversion, it is also called as hex double method. All these are division methods because we are dividing the given decimal number by the radix of other number system. So again the given decimal number, if it is having fraction, the integer and fractional part are separated and converted separately to their hexadecimal equivalents. So for integer part, if we consider the integer to be say decimal number 318, it will be divided by 16. the quotient and reminders are written. The quotient is again divided by 16 and the process is repeated till the final quotient is less than 16. Now this one is less than 16, so this final quotient is transferred to the queue of these reminders. If in the reminders the number is greater than 9, this 14 is greater than 9, so it is replaced with its hex equivalent. 14 is E in hexadecimal. So the reminders taken in reverse order, 1, 3, E is the hexadecimal equivalent of 318 decimal number. So 1, 3, E is hex equivalent of 318. Now let us see the fraction part. If we consider 0.65 as the fractional part of given number, it will be multiplied by 16. From the product, the integer will be taken aside as carry. Fraction part is again multiplied by 16. The integer taken aside, fraction again multiplied by 16. So this process can be repeated. As you go further, it just increases the accuracy of your answer. That doesn't make much difference. So you can go up to 3 or 4 places. And these carries now, if contain the number greater than 9, it will be replaced by its hex equivalent. So 10 is replaced by A. The carries taken in forward order give you the hex equivalent of given fractional number. So 0.65 in decimal is equal to 0. It is not just A66, it is 0.A66 in hexadecimal number system. And totally 318.65 in decimal is equal to 13E.A66 in hexadecimal, right? So in this way, decimal is converted to its hexadecimal equivalent. If we consider the table of hexadecimal counting, and here this 16, how this 16 is equal to 10, that you can now calculate using the division method. See, if you take this 16 and use the hexadecimal method for conversion of 16, decimal 16 to its hex equivalent, so you will divide this by 16, isn't it? 16 is the radix of hexadecimal number system. So given decimal number is divided by the radix of hexadecimal number system, 16. 16 ones are 16, so 1 will be here and remainder is 0. This one will be transferred in the queue of reminders. Reminders taken in reverse order gives you the hex equivalent. And what is the list of reminders? 1, 0. So 16 in decimal, 16 in decimal is equal to the reminders 1, 0. So equal to 1, 0 in the decimal. And in this table in front of 16, what is written? 10. I have just purposefully added this 16. You will find up to 15 only in the books. This 16 to understand how the hexadecimal count continues, right? So let us move further. Right, so that example is explained on this page also. We have discussed it. Hexadecimal to decimal conversion, the reverse process, and it is the method of weightages. Let us consider this hexadecimal number 4b2.3a in hexadecimal. So, weightages are calculated, individual weightages of these digits are calculated. How? This is the hexadecimal point, and the number which is near this hexadecimal point will be multiplied by power of radix. 16 is radix, 16 raised to 0. Next p into 16 raised to 1. Next 4 into 16 raised to 2. So powers are incremented, 0, 1, 2. If there is one more number beyond 4, it will be multiplied by 16 raised to 3. Okay, this is for integer part, and for fraction part, this 3 is multiplied by 16 raised to minus 1. This a is multiplied by 16 raised to minus 2. Now there are these alphabets b and a, so these are replaced by their decimal equivalents. So this b will be replaced by 11, this a will be replaced by 10, and when you calculate, when you multiply and find the individual weightages and you add these individual weightages together, you get the final numbers. So this is decimal equivalent of integer part of hexadecimal number. 4b2 in hexadecimal is equal to 1202 in decimal, and 0.3a in hexadecimal is 0.2290 in decimal, and this is written like this. Okay, so this is conversion of hexadecimal number to its decimal equivalent, in which we have used method of weightages. There are some questions given in the exercise. Try solving these questions, and in the next lecture we'll study some more interconversions between number systems.